Hello students, hope you are all fine. In the last class I explained you the numericals. Okay, up till here this was done in the last class. Okay, we did it in the class and I gave you homework up till numerical number 15. So today I'll start the class with 15th numerical only. See what it says. The resistance for A is given as A resistor is given as 4 ohm and for B it is 6 ohm. It is 6 ohm. Voltage is given of 6 volt. Now the resistors, how are they connected, students? See the first. They are connected in parallel. If two resistors are connected in parallel, okay, we can take it two ways. Either I can say R equals to RA into RB upon RA plus RB. Or I can take it as the way we usually take. 1 upon R equals to 1 upon RA plus 1 upon RB. Okay, so let us put the values. 1 by 4 plus 1 by 6, 4 6 are 24. So 12 is the LCM. I can take that away also. So take it as that. Okay, what do you get? 4 6 is 24, so 6 and here 4, 6 plus 4 10, 10 upon 24 is 1 upon R. So I can say R will be 24 upon 10, that is 2.4 ohm. So we can calculate the resistance. You can take the LCM 12 and then you can easily get it. 4 3s are 12, so 3 plus 2, that is 5 by 12. 12 upon 5 is again 2.4 ohm. Fine. Now power is P equals to V square upon R. V already is 6 volts, so 6 square upon R resistance is we have calculated the equivalent resistance which we have calculated, which is 2.4 ohm. So what do I get? 6 into 6 upon 2.4. Solving it, we get it as 15 watt. So that is what the power is. First part is done. Second part, what we have to do is power dissipation across each resistor, that is P we have to find out. What is the formula? We know P equals to VI. Okay. Now for the resistor A, I formula will be I equals to V upon R using Ohm's law. So we'll calculate I first of all for it, because then only for power dissipation we can calculate it for specifically A resistor. That is what is asked. So how will we calculate that? To calculate that, we will take the resistor A. Firstly, I'll calculate I current of the A resistor. I is equal to V upon R. V will remain the same for the two. It is 6 volt. So 6 upon RA, kitna beta? See, it is A resistor was given as 4 ohm. So 6 upon 4, 2 to the 4, 2 3 is 6, 3 by 2, 3 by 2 is 1.5 ampere. So I got IA, current flowing through the resistor A is IA is 1.5 ampere. Power dissipation, now P equals to VI is the formula. So V I'll take the same, still V voltage, but I current for the resistor A. So I'll take that IA, which is 1.56 into 1.5, 15 6 are 90, 9.0, that is 9 watt. Second part, we have to find out the power for B also. So the same rule, IB equals to V upon RB, 6 by 6, which is 1 ampere, 1 into 6, 6 is the voltage, P equals to VIB, 6 into 1, that is 6 watt. So this is how we can do question number 16. This is 16th question. Up till 15 I gave you a score. Okay. Let us move to the next 17th question. This is 17th one. What it says, see. EMF of a battery. EMF of a battery is given as 15 volt. What is EMF? When no current is drawn from a cell or battery, at that point the potential difference maintained across the terminals, that is called as EMF. It is given 15 volt. Internal resistance RB is 2 ohm. Resistance given in the circuit, there are two resistors given. R1 4, R2 6 ohm. How are they connected? In this question they are connected in series. Previous one they were connected in parallel. If they are connected in series, then R equals to sum of R1 plus R2 for that, and this is the internal resistance. We all know that it gets added up. So we'll add all the three. 4 plus 6 10, 10 plus 2 12. So I get the equivalent resistance as 12 ohm. Now current in the circuit I equals to V upon R. V is 15 volt and R is 12 ohm. 15 upon 12, we get it as 1.25 ampere. So this is the current in circuit. This is the equivalent resistance in the circuit. Okay. Now voltage we are asked to be calculated across the resistor R2. Apply Ohm's law. V2 equals to IR. I how much? 1.25 we know. Okay. Fine. And R beta series mein what remains same? You need to know this concept. That is what we are applying here. Otherwise I will be changed. The two are connected herein. The two are, in the previous question we calculated IA, IB. But here we will take I as the same. Why we are taking? Because In series, the current remains same. Okay, so that is what it is. Whereas in parallel, it gets divided. I1, I2, I3 like that. Equal. Fine. So I is 1.25. R resistor 2 is 6 ohms. So multiply that. That is 7.5 volt is what we get as the voltage across this resistor. Time is given as 1 minute and we have to tell the energy across this resistor. So we all know E is equal to, yes, V square T upon R. V is 7.5, so it's square into T time. But always remember, we always say that time should be in seconds. If we want to calculate energy in joules, time should always be in seconds. So it is 1 minute is 60 seconds, so that we have substituted as the value of time. Upon resistor R2, it was 6 ohms, so that's 6. Work out the calculation, 7.5 into 7.5 into 10 it will be. Why? Because 6 1s are 6, 6 10s are 60. So multiply and we get it as 562.5 joule as the energy across the resistor R2. Let us move to the next numerical, 18th numerical, what it says. See in 18th numerical what we are given. P we all know. What is the formula for P? P is equal to V square upon R. Okay. Now heat gate is equal to V square R, V square upon R into T. ये हमने अभी भी formula, heat energy is what? Heat gain is basically the energy only. Energy formula just now in previous numerical we have applied. P is equal to V square upon R. So energy comes out as P into T, right? So that is P is V square upon R into T. So this should be clear. Now for the 2, 1 and 2, okay, there are two different voltages given. For the 2, what remains same? Yes, the resistance remains same and it is given in the question. 2 resistors, same resistance. Voltage is different and time is different. Fine. Now the question is asking us if these two energies are same, heat gain and heat loss, then in that case we will equate the two. Yes, and this T2 time then will come equal to what? V1 upon V2. V1 square upon V2 square, and mathematically we can write it as V1 upon V2 whole square multiplied by T1. Why? Because R and R will be cancelled. So this is what it is. V1 given as 220 volt. V2 is given as 200 volts. Substituting the value 0, 0 cancelled. 11 upon 10 is what we get, square of that. Multiplied by the time. Students, see the time 1. How much is it given? Okay. Now we will convert it into seconds, and in seconds we get it as 300. So solve it out. 11 upon 10 whole square into 300. So 11 square is 121. 10 square is 100. So 121 upon 100. 2 zeros will be cancelled with it. So that is what I get on multiplying, on solving. I get it as 363 seconds. Now this is in second. You can leave the question in second, but if the question is clearly saying that give the time in minutes, so divided by what? Divided by 60. If I divide it by 60, I'll get the time in minutes at 6.05 minutes. So this needs to be understood and done very carefully. Let's see the next one, what it says. See, in the next question, we are given a voltage of 220 volts provided when the current of 8 ampere flows and the time given is 2 hour. We have to calculate now the cost. Beta, be very clear, cost के लिए क्या करते हो? We will firstly calculate the electrical energy consumed, and we know the commercial unit of electrical energy consumed is kilowatt hour. In the previous numericals, I have already explained you very clearly. Okay, so electrical energy consumed, we will calculate that at firstly in kilowatt hour. Okay, and we have discussed this also, how to convert watt hour into kilowatt hour by dividing it by 1000. And what is the formula for that energy, electrical energy? VIT. V is given 220, I is given 8 ampere. T time, I'll take it in hours because I have to calculate kilowatt hour, the energy in kilowatt hour, no more in joules. Because the bill that we pay, the cost which is calculated is for per unit. Per unit means, if you can see it, scroll it up, I have explained in the previous numerical, 1 unit is equal to 1 kilowatt hour. Right? So cost of energy we will find out. First of all, VIT, so 220 into 8 into 2, 8 to the 16 multiplied with that 3520 watt hour is what we get. Now divided by 1000 because I want the unit in kilowatt hour. So 3.52 kilowatt hour. For 1 unit, for 1 kilowatt hour, the cost is 4.5. Unitary method we will apply. For 3.52 kilowatt hour, it will be calculated by calculating the product of the two. For 1 kilowatt hour it is, the cost is rupees 4.5. So for 3.52 kilowatt hour, this much electrical energy consumed, the cost will be multiplied with rupees 4.5, and what do I get? Rupees 15.84 as the correct answer. Let's see the next one. Now what it says. Last question of the exercise, so please pay attention. Yes. Now we are given a geyser with a power of 1500 watt. This is the current rating of the geyser. How am I able to say that? Because very clearly I know that when power and voltage are given, it is the current rating. We get two values using it. Tell me. Yes, we get it as the safe limit of current I and R resistance also V square upon. So let us work it out. The first part question says find the current safe limit of current I is equal to P upon V. P is 1500 upon 250, 0 cancelled. Okay, and I get it as 25 6 are 150. So 6 ampere is the current flowing. Time is 50 hours given in the question. So to calculate the electrical energy cost, we all have just now discussed in the previous numerical. What will we do? We will calculate the electrical energy P into T in kilowatt hour. See, P into T. P power कितनी दी हुई है बेटा क्वेश्चन में 1500 watt. So 1500 into time in hours 50 hours. So I'll get 15 5 is 75,000 watt hour. But to calculate the cost per unit means for per 1 kilowatt hour, we have to divide it by 1000. 3 zeros will be cancelled. 75 kilowatt hour. Cost per unit energy. Now for 1 unit, or again I am repeating, for 1 kilowatt hour the cost is rupees 4.20. For 75 kilowatt hour, unitary method multiplied by 75, and we will get it as the total cost for the electrical energy, this much electrical energy consumed by what? Consumed by the given geyser electrical appliances, rupees 350. This much is the electrical energy consumed, 75 kilowatt hour, and the total cost for this much amount of electrical energy will be rupees 315. Okay, so you have to complete all the numericals, remaining numericals that we have discussed today, and till the next class, do question answers. Okay, God bless you all. Thank you so much.